Okay, this video is for both third and fourth period. Now, third period has this yellow packet, but does not have the pink one yet. So pass out the pink one to third period. Fourth period should have both, but theirs are actually both yellow. So fourth period, you already have this, it's yellow. Remember how we had two yellow packets? Third period already has the yellow one, and they're just going to receive the second one today. We're going to go over a handful of problems to help you out with maybe some questions on the packets, and then skip through the problems, and the rest is for you to do. Okay, so on the first page of the yellow packet that says properties of parallel lines, we're going to look at number 4 first. Now it says identify all the numbered angles that are congruent to the given angle and justify your answer. So congruent, when we have parallel lines, like right here, I know these are parallel because see those double arrows? That tells me they are parallel. When they are parallel and cut by a transversal, we have a bunch of angle relationships that happen with congruent angles. The only one you should stay away from is consecutive interior angles. Consecutive interior angle are supplementary. All the other ones, vertical angles, corresponding angles, alternate interior, alternate exterior, those are congruent, so we can use those. Now angle 75 is this one in the inside. Remember our tube idea, water spurting out? Angle 75 is on the inside of the tube. So we have a few things for the inside. Angle 75, now consecutive interior is also on the inside, but we're not going to use that right now because that's supplementary. We're looking for congruent. Okay, so on the inside I do have alternate interior. 75 is the top left, 9 is the bottom right of the interior. So those are congruent. Angle 75 degrees is congruent to angle 9 by, it does say justify, so we have to say why, alternate interior angles. Okay. We also have some vertical angles. 75 and 6 are vertical angles because they two lines intersect, opposite angles are congruent. So angle 75 is congruent to angle 6 by vertical angles. And we also have two intersections. We have this top intersection and this bottom intersection. 75 degrees is the bottom left of the intersection. This bottom left is 11, angle 11. So they correspond to the same place of the intersection. So angle 75 is congruent to angle 11 by CA, corresponding angles, since they correspond to the same place of the intersection. If you want to flip it over, the back side of that page, down at the bottom, there's a map. I'll help you with the map one. Okay, down here at the bottom, says, I guess it's not a map, this is the quilt block. Mrs. Jensen made a quilt for her nephew. The pattern of one block is shown at the right. If measure of angle 1 equals 60 degrees, so I'm going to write that on here, 60 degrees, and the measure of angle 2 equals 115 degrees, so again I'm going to write that on there, 115 degrees, are the two strips parallel. Okay, we have two directions we can go. Given they're parallel, we can use, and a transversal that cuts through the parallel lines, we can find out that angles are congruent by corresponding angles, alternate interior, alternate exterior, CIA are supplementary. Okay, and we can reverse it. Given that we have these angle relationships and a transversal, we can prove that they're parallel. So let's see what we have here. These two gray strips, I'll actually highlight my gray strips in pink, are cut by a transversal. That would be this diagonal. But we don't know if those pink lines are actually parallel, but we could prove it with angle relationships if they are, or disprove it if they are not. Okay, so if these two lines are parallel, which we don't know for sure yet, cut by a transversal, Here's our tube. Let's look at the angle relationship. 60 and 115 are measure of angle 1 and 2. They're both on the same side of the transversal, so we cannot use alternate interior. Alternate interior would be like 60 and this angle down here. So across the street neighbors would be CIA. Okay, the camera wigged out for a minute. I was saying across the street neighbors would be CIA, corresponding interior angles. Now, corresponding interior angles are supplementary. Supplementary means they add to 180 degrees. So let's see if these add to 180 degrees. 115 plus the 60, add them up. 5 plus 0 is 5, 6 plus 1 is 7. Ooh, 175 degrees. So what does that tell you about these two pink lines? If they do not add to 180 degrees, then it tells you that these parallel lines are not actually parallel. We thought they looked parallel, but they're not. So our answer is the two gray strips are not parallel. By CIA, corresponding interior angles, angle 1 and angle 2 should be supplementary. However, measure of angle 1 plus the measure of angle 2 does not equal 180 degrees. Therefore, they are not parallel. It does say explain, so you have to explain why. Okay, flip it over to the next page. I'll help you with number 10. A couple of problems on this, actually. This page says proving lines parallel. Okay, we're having an autofocus issue here. There we go. Proving lines parallel. We're going to look at number 10. Find the value of x for which given a and b are parallel. So since we're given that, I'm going to mark parallel and parallel. I'll zoom this in too a little bit. Okay, let's see what we have. A and B are parallel. I'm going to highlight those so I can see them better. And we have a couple transversals. The transversal I want to focus on is the transversal that has this 12x and the 3x. This 6x isn't even close to the parallel lines. So I'm only going to look at this transversal. Now careful, the 3x is not actually on the outside. It's on this little inside section, so that's a little deceiving. This angle, 12x, if this is my tube, is on the outside, and where the 3x looks like it is, but it's actually representing the inner angle, we have an angle up here. 12x is in the bottom right on the outside. This angle up here is on the bottom left on the outside. So those are alternate exterior angles. Alternate exterior angles are congruent. So we can actually say that this angle out here is also 12x because they are congruent by alternate exterior angles. Now let's look at what that creates with 3x and 12x. 3x and 12x forms a linear line. 3x and 12x together form a linear line. So that means they're supplementary. Those angles are supplementary. Supplementary means they add up to 180 degrees. So I can just take them and add them up. 3x, which is this little inner angle right here, plus the bigger angle, which is 12x, equals 180 degrees, and solve for x, and that's what we were asked to find, is x. 3x plus 12x is 15x equals 180. Get rid of the 15. This is 15 times x, so we divide by 15. X equals, well, let's see here. Calculator, 180 divided by 15 is 12. Now this is not a degree. This is the value of x. A degree would be a measurement of angle, so do not put a degree. And we actually found x without even using the 6x. This 6x is just there to throw you off. It's called an extraneous information. It's extra information that you don't necessarily need. Okay? Looking down below, same page. Maybe I should zoom out. We're having an autofocus issue here. That's a little better. Okay, same page at the bottom. Let's look at number 16. Determine the value of x. There we go. For which C is parallel to D, and find the measure of angle 1 and 2. So we want to find the value of x. We're not told that C is parallel to D. We want to find the value of x that makes C parallel to D. Okay, C and D, if we want them to be parallel, then look at 1 and 2. What type of angle relationships are they? Angle 1 is in the top left of the tube on the outside. Angle 2 is on the bottom right. Top left, bottom right of the outside. So we would want to create these to be alternate exterior angles. Alternate exterior angles are congruent if C and D are parallel. So if we want to make C and D parallel, we need to make sure 1 and 2 are equal to each other. So I'm going to set them equal to each other. Angle 1 is 100 minus x, and I want to equal it to angle 2, which is 40 plus 2x. Now I'm going to solve for x, because it asks us to determine the value of x, and then it asks us to find the measurement of the angles. So we have two things to do. Finding x, put my x's together, move the smaller x by adding it over. I get 100 equals 40 plus 3x. Subtract away the constant. I get 60 equals 3x. And divide by 3. So x equals 20. Again, x is not a degree. Do not put a degree. Now it also asks us to find the measurement of the angles. So now that we know x, we can find the measurement of each angle. Measurement of angle 1, we're going to do 100 minus our x value, but x was 20. So I'm going to do 100 minus 20, which equals 80. Now this one's a degree because it's the measurement of the angle. So do put a degree sign. Same thing with angle 2. I'm going to take angle 2 is 40 plus 2x. 40 plus 2 times, but our x is 20. I get 40 plus 40, which also equals 80 degrees. Interesting. Why do these both equal 80 degrees? Well, if C and D are parallel, then 1 and 2 have to be congruent by AEA. And that was our goal, was to make these two parallel. So we had to make angle 1 and 2 congruent, which is why they are both 80 degrees. Okay, flip to the last piece of paper where there is the map. At the top it says parallel and perpendicular lines. We're going to look at this map one. A developer is planning a new housing complex. The map of the complex is shown at the right. Assume that all streets lie in a plane. If Washington and Lincoln streets are parallel, so Washington and Lincoln are parallel, what must be true of angle 1 and 2? Well, you can see Eagle Road here cuts through Washington and Lincoln. So angle 1 and angle 2. There's an intersection here. Angle 1 is the top left of the intersection. There's an intersection here. Angle 2 is the top left. They're both top lefts of the intersection. So they correspond to the same place of the intersection. So by corresponding angles, angle 1 must be congruent to angle 2 by CA, corresponding angles. I'm going to erase my lines here, so I can do part B. Which streets must be parallel if angle 3 is congruent to angle 4? Well, I see a transversal here. If those are congruent, then we must have parallel lines. What type of angles are these? These are parallel, if Washington is parallel to Jefferson, those congruent angles that we're told are congruent, 3 and 4 are inside. They're inside, so they must be alternate interior angles, because this is top left of the intersection, this is bottom right of the intersection. So if those are parallel, then Washington Street, or excuse me, if these are congruent, then Washington Street is parallel to Jefferson Street. Always justify, especially when it says justify. So we can say by alternate interior angles. Okay, again, I'm going to erase my lines here. So we can do part C. Eraser everywhere. Okay. Measure of angle 1 is 90 degrees. Let's write that in. 90 degrees. And your answers from part A and B are true. If that's 90 and our answers are true from above, so we had angle 1 was congruent to angle 2, we knew that Washington was parallel to Lincoln. And we also knew that Washington is parallel to Jefferson. So if Washington is parallel to Lincoln and Washington's parallel to Jefferson, what does that tell you about Lincoln and Jefferson? By the transitive property, Lincoln and Jefferson are also parallel to each other. So all three of these are parallel to each other. If that's all true, to what roads is Eagle Road perpendicular? Eagle Road cuts right here, but look, we're told right here that intersection is 90 degrees. Since these are all parallel because of the transitive property, it tells us something about angle 2. And it tells us how the intersection to Jefferson Street would be. It means they're all going to be perpendicular. So Eagle Road is perpendicular to Washington Street, Lincoln Street, and Jefferson Street. By the transitive property. Because if Washington is parallel to Lincoln and Washington is parallel to Jefferson, then Lincoln and Jefferson are also parallel to each other. And if Eagle Road, which is perpendicular to Washington Street and also intersects with Lincoln and Jefferson, then it has to be perpendicular to Lincoln and Jefferson as well. Okay, one last one on the back side of the whole packet, number 8. Oops, there it is, number 8. Draw the map of a town to meet the conditions below. Based on the map, explain, so that means we need to do some writing, explain how each street is related to the other streets. First Street is parallel to Third Street, so let's draw a picture. First Street is parallel to Third Street. We notate that they're parallel with a matching arrow. Okay, now Second Avenue is parallel to Third Street. I'm going to put second between first and third. Now, if first is parallel to third, and third is also parallel to second, doesn't that tell you first and second are also parallel by the transitive property? It means all three of them are parallel. Third Street is perpendicular to Main Street, so we have Main Street coming down through. and it's perpendicular to 3rd Street. But like I just said, if 1st is parallel to 3rd and 3rd is parallel to 2nd, then 1st and 2nd are also parallel by the transitive property. So if Main Street cuts through all of them and is perpendicular to 3rd Street, then it also has to be perpendicular to 2nd Street and to 1st Street. Main Street is perpendicular to North Avenue. Main Street is perpendicular to all these guys. North Avenue must run left and right. Now North Avenue, would you put it after 1st Street or before 1st Street or after 3rd Street or in between? I'd probably put North Avenue, if it's anything like Utah, right next to the 1st Street, North Ave. And it's perpendicular. So let's explain how each street is related to each other. North is parallel to 1st, which is parallel to 2nd, which is parallel to 3rd. Main is perpendicular to North, 1st, 2nd, 3rd. And this is all because of by the transitive property. Okay, so for the rest of class for 3rd period, I'm going to start with 3rd period. The rest of class for 3rd period, you are to continue working on this packet. Let's see if I can zoom this out. Oops, wrong direction, sorry. Still wrong direction. 3rd period, you should continue to work on this packet, and substitute is going to give you this pink packet. And you have the whole class to work on both packets together. Working is different than socializing. You can work together without having an uproar of socialization going on. For 4th period, you already have both of these packets, but both of yours are yellow. And you may have already turned this one in. So if you've already finished this one and turned it in, great for you. Make sure you finish the properties of parallel lines packet as well. So both packets need to be completed. And again, 4th period, both are yellow. 3rd period will need to receive the pink packet. And we have tutoring Wednesday morning in Mrs. Campbell's room right next door. And we also have tutoring. I will be back for tutoring on Thursdays after school.